We're going to do some pretty cool science. You know, I used to do television weather full time, so I am an actual working scientist, and I still do that as a part-time scientist, if you will. The two stations that I mainly do weather in right now are in Evansville, for those of you who might live in that part of the country. So Southwest Indiana, Southeast Illinois, and West Kentucky at a station called Eyewitness News, WEHT, WTVW. And then I'm also a chief meteorologist in Lexington, Kentucky. So if you call Eastern Kentucky home when you're watching, you probably see me do the weather here at WTVQ or ABC 36. And that's the studio that I'm in right now, getting ready to do some back to school science. As many of you know, we are about to head back to school for the first time in a pandemic. We continue to, as a unit, as a team, synergize to conquer COVID-19. And as we do so, we have to do so with caution. And there are so many questions as schools across America are starting to plan, send out surveys to parents, to attempt to get students back into the classroom, but safely back into the classroom so that the kids and the teachers and those at the school can be safe. Now, from my understanding, you know, here in Kentucky where I live, there's going to be many different options for educators, for school districts to send kids back to school. One would be in person. Another would be, you know, altering the days. Maybe kids go to school on a Monday, Wednesday. One group goes to school on a Monday and a Wednesday, and the other group goes on a Tuesday and a Thursday. And then when you're not in the actual school building, you are doing a more of a virtual kind of learning. You and I both know that when it comes to science education, virtual learning is not best, especially for those kids who love to do hands-on science, and that's the majority of the students here in America, around the world. So it's very important that whenever we are heading back to school, and some of those students who are virtually learning have the ability to do hands-on science. So some of the things that I'm going to show you today will include ingredients from a local dollar store. Why did I pick that store? Because every rural community and every community has one, and it's affordable science. So we're going to do 4 experiments. One's going to be using a Ziploc bag and pencils that you find from your pencil case to talk about matter, anything that takes up space and has mass. Then we're going to talk about pushes and pulls, and we're going to use the spiral part of a notebook, again, school supplies, and a dowel rod to launch that across the room. Then I have an index card, something you might find in your school supply box, and a vase of water, and we're going to talk about an illusion and basically something when it comes to what our eyes see and how our eyes take in information. So processing that information and eventually what our brain tells us. And then we'll talk a little bit more about matter. We might use this, something that's in the classroom or in your pencil box, some dry erase markers and a plate to do something that has to do with matter. But I told you I was at a TV station. I wanted to quickly give you a tour of the TV station, show you how we do the weather, and then we'll get back to these science experiments. So I'm going to actually remove the camera from my tripod, and then I'm going to kind of take you around the studio and show you what's going on. So where I'm at is a place that a lot of folks will do the news. Behind me is another place, but let me show you where I do a lot of my work, and that's right here as a meteorologist in the Weather Center. You'll notice over to my left, there's actually a croquis wall. So basically, whenever you saw, but the graphics that I see behind me, and again, this is, you know, scientists doing work. This is one of our weather computers, basically, that we get all of our weather data, and we analyze that weather data as a meteorologist, and we present that to you bottom line. So that's kind of what the studio looks like. You'll notice on the other side, the part that you don't see, the bright lights, some cameras over here as well. So this is what your typical studio is going to look like here in America and really all around the world.
Oh, Jason,
Oh, there we go. I think I hit mute. Am I back on? Can you hear me now?
Good to go.
Okay, good. So just wanted to kind of show you what we did as a scientist and all that good stuff. So everyday ingredients from around the house right here from your local dollar store, if you will. Wanted to make sure that every kid has access to it. I want to know your thoughts. You know, as kids are heading back to school, what do you think? Do you think you're going to see more of the at-risk kids attending school and more of the middle class and upper class kids basically homeschooling or parochial schooling? What are your thoughts on that? Do you think it's going to be equal for everybody? I'm not sure what's going to happen come the fall, but it's a good thing to look at. And, you know, here in Kentucky, they recently did a big survey of what access kids have to the internet. And it turns out that internet access in rural communities isn't just the problem. Actually, in big cities like Louisville and Lexington, there are some kids in those cities that don't have access to the internet. So virtual learning is very difficult. And if they do have access to the internet, it's a phone that has a limited number of minutes on it. So what about computers? Well, most kids, at least in Kentucky, don't have a computer. They either have a device like an iPad or a phone. So how can you really do intense work on those two devices and make it work is the big question. So we have to really think about that as well. And think about how, you know, they can get their hands dirty with science. Well, let's start with matter. Matter is anything that takes up space and has mass. So if you have a second grader or a fifth grader and they are covering next generation science standards, like the majority of America is, they're going to hit matter in those grades, as you know, teachers. So when it comes to matter, we can describe matter by its observable properties. My five senses, you know, typically we don't taste, you know, when doing science, so we leave that one out, but we can safely smell it, touch it, look at it, feel it. I have a bag right here of water. It's just a Ziploc bag. It could be any type of bag. And you'll notice it's filled more than 3/4 of the way. This bag is made out of plastic. The water on the inside, I can see through it somewhat. And it's got some mass to it. What I want to do is be able to take these pencils and describing these pencils, you know, it can write, it's shaped like a cylinder, a very thin, long cylinder, so on. I want to be able to jab these through here without the water leaking out everywhere, leaking out all over the place. You know, basically how this bag is made, it allows us to do that. So we're not going to get the polymers to high school chemistry, but basically, as you know, matter is made up of small pieces. The smallest unit of matter is an atom. You put together atoms and you get molecules, and eventually you can link this long chain together and you get polymers. So this bag is made up of a bunch of chains, if you will. We want those chains to link up around my pencil. If I do this right and with patience, it should be fine. I'm going to go a little closer to the actual camera here so you can see this. What I'm going to do is push this through here slowly, and you'll notice it's not leaking. Why? It's science, it's not magic. So basically, the science here is that the smaller pieces that make up the plastic bag are holding hands tightly, if you will, creating those polymers that are linking up around the pencil. Now notice that my pencil is not shaped like a stop sign. It's a round pencil. It's very important that you get the round pencil versus those that have the edges on it. Let's do another one in here. You know, it's great if you could do this above the teacher's head or that best behaved student in your classroom, right? There we go. We'll do 3 more, so that'll give me a total of 5. Pretty cool experiment. What if you tried different bags? What about if you try different pencils? What about the amount of different water in the bag? So different variables that you can add to this. So we have 5 pencils. The bag is not leaking any water. Science is the reason why this is happening. Pretty cool experiments that you can try right there, maybe as a bell ringer, or have the kids just explore at home over the couch, right? Okay, maybe not over the couch, but you get the point. Pretty cool experiment, though. By the way, I will have all these experiment guides put together into a back-to-school science guide, and you'll find that at the website, hookedonscience.org. Just give me about 24 hours to put all that together or to link all those experiments away from the website. But pretty cool. What's going to happen if I take the pencil out? What do you think? Well, the water's going to leak out, right? And it's going to go everywhere, all over the place. Because while those tiny pieces of matter are holding hands tightly, it's very difficult for them to actually start to link all the way back up together. Okay, it looks like it's about 1:51. I want to make sure we get through some more of these before it's time to go and chat with Dave a little bit. But you'll notice here with my notebook, I have unwound some of it. And you have the spring. So a push or a pull is a force. A push or a pull is a force. Some things require more of a push or a pull. Depending on the mass of an object, depends on how much of a push you have to push on that object to make it go a specific distance. We also know that as the law of inertia. Basically, you see it all here, or the second law of motion, force equals mass times acceleration. I'm going to unwind this so that I take this completely off of here. Typically, I use a plastic one. And, you know, there are some notebooks that have the plastic and some that have the metal. You may have some old teacher's editions that are out of date that you could do and do a different size. So this is this size. You could do a bigger one, a smaller one, measure the distance on how far it might go. Then I have my dowel rod, and I'm going to place this right on my dowel rod like that and store some energy. So this is all about energy. Fourth graders had a lot of energy when it comes to next generation science standards. So I'm going to store the energy. That's called potential energy. And then I'm going to convert or transform that energy from potential to kinetic. So as I let go of this, we'll transform some energy, because you and I both know energy can't be created and it can't be destroyed. So what it should do is launch right through the air, and you could measure on the floor how far it goes, and you can do the different variables by the different sizes of springs. So as I put it right here, oh, there we go, we hit the actual camera, but yeah, it launches pretty far. And the reason why I use plastic is, you know, kids will be kids. And, you know, anything toward the eye is bad, but, you know, a plastic thing versus a metal thing is going to be a lot less dangerous, if you will. And they should, of course, have their goggles on. But that's something you can really form, create, design, launch these across the classroom, and measure, add some math in there, all of science, technology, engineering, mathematics. Okay, I have another one over here. This other one that I have is a glass of water. Now, this glass of water, let's call it a vase, because it's really not a glass. It's a big glass. If you're drinking out of this, your soda, it's a little too much soda. But here's the deal. I have filled it more than 3/4 of the way with water. It's just regular tap water. It doesn't matter if it's warm or if it's cool. You know all about, I think we did this in the 4th grade if I remember correctly, information processing. So basically our eye sees something, then it sends a message to our brain, and then our brain takes that information and tells us to do something. So for example, if I didn't eat breakfast and I smelled pizza, when I smell that pizza, dentist sends a message to my brain, my stomach's been growling, my brain puts those two things together, tells my feet to walk to the kitchen or the cafeteria. So what I have is my vase of water, and then I also have this, an index card that has an arrow on it. It's just basically an arrow that's drew with a Sharpie, okay? And what I'm going to do is place it right behind here. And I want you to pay close attention to the arrow. I'm going to scoot this as close as I can right here so that you can see this. I'll try not to make too much of a mess. Okay, here we go. I'm going to put it here. Do you see the arrow? Okay, now I'm going to move it away. What happened to that arrow? Do you see the arrow? Now I'm going to move it away. Do you see the arrow? Are you getting it to where the arrow is reversing? See the arrow one way. Now I'm going to move it away, and the arrow goes the other way. One way. This is all about, you know, light travels in a straight line until it hits something. When it hits something, it can do one of 3 things. It can reflect, refract, or absorb. So it's all about the light refracting. So the light from the studio here, these lights, shining through the first layer of glass, and it's bending. Then it's going through the actual water, and it's bending again. Then it's going through the glass back here, and it's bending. And as all of that information is taking on, it kind of looks like the arrow is reversing, but it's really just science, not magic. Our eyes are seeing this, and it's kind of playing a trick on us. It's taking that information in. Let me show it to you one more time. There's the arrow that way, okay? And then I'm going to move it away like that, and you'll notice how it reverses. Let me do it again. This time I'm going to get a little bit closer. Put the arrow right there. See it? Okay, move it away. It reverses. The reversing arrow, just by using school supplies. Pretty cool, right? You'll notice right there, just like that. Pretty cool, as it reverses. Goes forward, goes the other way. And it's all about the light. You know, the vase is transparent. I can see through it. Stained glass is translucent. This notebook is opaque. I can't see through it. So you got to make sure that you have a transparent vase that allows you to do just that. To allow the light to come through, let it bend at different angles, and then it looks like it's reversing that specific arrow there. Okay, this next one's pretty cool. You know, these experiments have been around forever. Nobody owns a science experiment. They've been around forever. The whole goal is for us educators to share these so that we can get kids excited and hooked on science, if you will. So some of these go back to Mr. Wizard's time. If you know who Don Herbert is, you may have watched him back in the 50s and 60s on NBC. And of course, Bill Nye had a lot of these experiments, Beekman's World, and then Teachers Across America. So some of these you may have seen before, and you just add your own little twist to them overall. This is one that's, I wouldn't say fairly new, but it doesn't go back to Mr. Wizard's time, because I'm not sure. Well, we used to use chalk back then. It wasn't these dry erase markers. So we know it wasn't around at that time. I have a glass plate, okay? And then I have a marker. What I'm going to do is on my marker, with my marker, I'm going to just draw, let's just do a circle, okay? So I've got a circle on there. See there? What I'm going to do next is pour some water on this plate. So I might look at the ink, describe this. Again, we're talking about matter. Look at the ink. How's the ink made? All that good stuff. Now, in order to fully see this, I need my helper here to remove the camera, and they are going to hold the camera above the plate as I pour the water on here. It's 1:58. I know at 2 o'clock, Dave and I are going to chat a little bit. Just like all the other, and that'll be 20 minutes that are up for the science experiments since we started about 40 after. Okay, so here's what we're going to do. I'm going to kind of guide you just a little bit. We'll see what happens. Will this lift up? I'm going to pour the water on there, and we're going to move this around, and the goal is to try to get this to lift up off of there. Sometimes you have to use oh, there you go. It didn't go on my complete circle like I wanted it to, but you know, maybe you are in second grade and you're trying to master math or a certain math concept. You can have the kids write on the dish here, pour the water on it, and remove their math work from their paper, or in this case, the glass dish. But you saw how it kind of lifted up off of there. Another matter science experiment that you can do there to get your kids excited about science overall. But that one is a pretty cool experiment at the end of the day. Okay, let's put this back up there. And you could try different markers, the generic markers, the cheaper markers. You could try different plates. I can tell you, I have not had any luck with styrofoam plates, but you know, as a scientist, we try many different ways with hopes of trying to get the best results at the end of the day. So that's 4 back-to-school science experiments that use everyday ingredients from around the house. So if there's going to be a lot of virtual learning, you want kids to have access to those materials and still do science at home. With that in mind, that's why I selected a few ingredients from, you know, a local department store that I know that most communities have to do some cool, amazing hands-on science. We don't want kids to come back to the classroom, you know, after we get this vaccine, and then they hadn't had science since they left in March of this year. So we still want them to do the hands-on science. We still want to make that available to every single student in America. And to do so, they've just got to be able to have those resources available overall. So those are my experiments as we near the 2 o'clock hour that I wanted to show you. Any specific questions that you may have, Dave?
Hey, Jason, how you doing? Thank you for that. It was great. Can you hear me okay?
I could hear you, yes, sir.
Great, great. Yeah, this is fantastic. Thanks for the tips. You know, I saw a couple hashtag affordable science.
Oh, are you still there?
Oh, can you hear me?
Oh, I can hear you now, yes.
Okay. Yeah, I saw a couple of people push hashtag affordable science. And I guess that's the whole idea, right?
Mm-hmm. Affordable science, to make sure that, you know, you can, as we all know, not every single school district and every single teacher has the ability to buy all the top-notch supplies. So my goal is to help educators do science affordably.
Yeah. Well, if you're going to do it at home, what are you going to do, you know, as a parent, right?
Yeah, exactly. You know, you want those kids to be able to find the ingredients safely from the kitchen or from around the house. And every single experiment that you find at hookedonscience.org includes just that, ingredients from around the house, including an NGSS science guide with I can statements as well. So if teachers are looking for that, they can always click on the experiment of the week, and that's the latest one. And they can go to the experiment archive to get an archive of all of those science experiments.
Oh, this is great. So we're going to send, everybody's asking, I see people posting the links. Thank you. We're going to put all these together. So if you're here in the Zoom chat, you're on the email list, you'll get a detailed email within the next 2 days with all the links of everything presented, including Jason's stuff. You know, I noticed you have an app that people can take advantage of.
Yeah, if they go, and I'm not sure, are you seeing this as backwards in your screen, or does it look normal?
You're small, so I'd have to zoom you in.
Okay.
It looks normal to me.
Okay, good. If they go to hookedonscience.org and click on Science on the Go, in your phone, you know, go to your browser and click on Science on the Go. At the bottom, it's actually going to pop up that says, put this on your home screen. And it will create a little app that's friendly. So a lot of parents and a lot of educators too are using this, and especially parents when it comes to little Jimmy sitting there in the doctor's office. So they'll say, hey, watch Mr. Science. Or for that matter, you know, maybe you're in the grocery store and you're trying to grocery shop, and, you know, at least kids are getting the science that way, and they're not just goofing off on their phone and playing some wild game overall. So lots and lots of parents have downloaded that. Just click on Science on the Go, and then it'll give you the option at the bottom of the screen to put this on your home screen. And so it'll be like an app feature. So yes, it's an app. Mm-hmm.
That's cool. I think it's a great resource for people to know about. We'll include your website. I think I saw it right on your website, so I'm pretty sure people can find it right away. But we can include that as well too. And were you doing science kits, like science in a box kits? Tell us a little bit more about that.
Yeah, you know, depends on the school district. You know, there are some school, bottom line, when I go into schools, whether it be in the fall, until we get a vaccine, there's certain things that I'm having to follow. And that is, I wear a mask, a face shield, gloves. You know, I've eliminated science experiments that have to do with air, blowing air from the lungs, fans, leaf blowers, because we don't want to mix up the air, as we all know. And I think most recent research, if you will, has indicated that those germs of COVID-19 can stay in the air a little longer than what we first thought we could expect them to stay there. And we know that it is transferred from person to person. One of the ways is through the air. So I've taken the precaution of doing away with any kind of experiment that blows air around. Classroom size only, no assemblies allowed. Now, if you don't want to do that and your school's not doing that, there's Hooked on Science in the Box. So basically, it's based on specific science standards from NGSS. I send you a box. Your students and I do a science experiment via Zoom. This includes a teacher's guide, a science guide for the students, and cards. So I've developed some cards that reinforce specific science standards from next generation science standards overall. Also, there's a new thing that I'm doing with virtual science night. So a lot of family science nights have been canceled come the fall because of COVID-19, obviously. So basically what we do is I send your families a bag of science. They join me on Zoom, and we do our family science night via Zoom. And then, you know, they also have the chance to win some prizes. So just like everyone else, we're all evolving to this virtual concept, but still trying to make it hands-on at the end of the day, in hopes that once that vaccine is available, we can get to a new normal and get back to doing hands-on science in the classroom and stuff like that, hopefully coming the spring of 2021.
Right. Yeah. Jason, that's great. You know, there were quite a few questions about high school students. So I know from the stuff I know, you do a lot of elementary, great activities for elementary, which are generally hard to find. But then what are your thoughts on activities for high school students?
You know, when it comes to the high school setting, I do some high school programming, you know, especially when it comes, high schoolers tend to love the big giant experiments when we shoot fireballs, catch teachers on fire. Okay, maybe not that one, but, you know, the big experiments that include fire and big explosions and things like that. So what I try to do is hit a lot of physical science, because that's what my degree is in. So I usually work with a lot of ICP students, Introduction to Chemistry and Physics, or a lot of physics students overall. You know, across America, it's just going to be hard, even when it comes to biology and even physics and especially chemistry, because, most of the time you have 2 or 3 students in a lab, maybe more. And, the virtual stuff is great online, but there's nothing like seeing it in front of your eyes and making it work, in front of you. It's just going to be so very difficult over the next few months as we go into 2021 and hopefully kind of conquer this COVID-19. But yeah, I do hands-on science experiments, but that's not my focus for high school. And when I do go into high schools, I mainly focus on physical science overall. But if a school sends me a message or a teacher and says, Jason, I'm trying to do this, I'm trying to teach you this concept, do you have any suggestions? Or for that matter, can we design a program around your needs? I do that often too for high school students. But the majority of the stuff that you're going to find there is going to be K through 8, especially K through 5.
Okay, got it. And, I see a few people now said meteorology. They'd love some materials on meteorology.
Yes, there is a Hooked on Science in a box called Weather and Climate. So we talk about, weather and, how because of the earth is shaped like a sphere that we have weather. If it wasn't, we wouldn't have weather, and how we get that uneven heating to get our weather, and talk about weather over a long period of time called climate, and how we should be important to making sure we're good at taking good care of the earth and so on. So there's some experiments with that. So there's a guide there and a box on that overall. All you got to do is just go to hookedonscience.org. And at the bottom here, I don't know if you can see it, this is virtual science programs, Hooked on Science in the box. And there's other resources here too. What I've done is I've picked some of my good partners. So if you're looking for high school stuff, middle school stuff, elementary stuff, I know my friends at STEMfinity offer all kinds of amazing STEM products as well as STEM resources. They have like an at-home STEM page as well. Just click on it there from that page, and there's your PocketLab link as well. For you, Dave, PocketLab, are you seeing a lot more people buying those and taking them home and doing the science at home with PocketLab?
Yeah, we're trying to tackle the same problem. I mean, how do you do a physics experiment at home? So we have, we're talking about, we'll probably talk about this a little at the panel, but, that's why Cliff demoed a fairly inexpensive dual temperature probe this morning with the idea is that's something you can do at least temperature experiments at home, which are really fundamental. But yeah, we're seeing questions about this. And I would say the problem is, and this is going to be the topic of the noon Pacific panel in an hour or so, is the schools still don't know what the situation is, as you know, right? Are kids going back? Are they going back hybrid? Are they going to be remote? Right?
Right. Yeah. That's a big question. And that's why I think so many parents are just confused, and it's not anyone's fault because nobody really knows. They're frustrated, they're confused, and a lot of them are going to homeschool. I think was it West Virginia or maybe Virginia? They had a website crash because there was a significant number of families going to send their letter of interest to homeschool starting in the fall. So their whole website crashed because of the significant number of families wanting to homeschool, because it's just so uncertain. What do I do? Is my kid going to wear their mask? If they don't wear their mask and little Susie takes it from him and wears it, is my kid going to get sick? There's so many questions out there that just parents are confused and looking for the best way to get their kids educated, not only science, but all of it. It's kind of a unique time.
It's a unique time. So we're going to talk, if you want to tune in, if you still can, but you'll probably be able to see the recordings. And we have one of your neighbors. I saw at least one shout out from Fort Wayne, Indiana. We have a STEM coordinator from there. So they're going to talk about their plans. It's a pretty large school district. Their planning process. Nobody has a plan written down. Everybody's in process right now from what I can see. So.
Yeah. I know here in Kentucky, they announced some final plan, but from the education department, they sent it out to all of the school districts saying, it's really going to be up to you, but here are your options and here's how we want you to do it at the end of the day. I just have a feeling that we're going to see a lot of homeschool, a lot of, people trying to do it from home. But my only concern for that is it going to be done correctly? And hopefully not only that, but we offer parents the resources so that whenever they do get back to school, say the spring of next year or the fall of 2021, that we don't have a ton of RTI. It's going to happen anyway, but we don't want so much so that, some kids are grade levels behind.
You should probably say what RTI is.
Oh, basically, it is report to intervention. So it's intervention. And a lot of teachers, they know what I'm talking about when I say intervention. And that's basically, if you're behind, we may pull you out in groups to help you get to the next level overall. And it could be as a whole classroom. Maybe the whole classroom scored a certain grade that you didn't expect, and you're having to go back and reteach a specific concept. So RTI, a lot of schools have built into their school day a period that might be RTI or exploration for those who don't need the RTI. I just have a feeling there's going to be a lot of reteaching and a lot of intervention come either the spring or the fall of next year.
We have a lot of people typing what it is, but I'll remind you, we have about a third of the audience is international and probably doesn't know, or probably has some version of that, right? So, Jason, we got to wrap up and go to break. Thanks you. It's great to see you again. Really appreciate it. We'll have all your resources. So everybody should join the Facebook group. We'll post the link to that because Jason posts his resources there. Stuff will go there. We'll send them out later in follow-up emails. And I encourage you to go check out Hooked on Science and enjoy the stuff that Jason has for you.